Welcome to this explainer. You know, math doesn't always just hand us the numbers on a silver platter. Sometimes it really makes us work for it. But here's the incredible secret. Even when pieces seem completely missing, we actually have the power to decode them. It's like a giant puzzle. So today, we're putting on our detective hats and jumping straight into the fascinating world of finding what's hidden in geometry. To set the stage for our little detective narrative today, I want to share a really beautiful piece of wisdom from Proverbs 25:2. It says, "It is the glory of God to conceal a matter. To search out a matter is the glory of kings." I mean, think about that for a second. Solving geometry puzzles isn't just about passing some math test. It's practically a royal mission of discovery. We get to use our wisdom, our logic, and our reasoning to uncover a hidden truth.
So, here is our mission plan for today. We're going to cover 1. The glory of discovery. 2. Why angle relationships matter. 3. Your geometry decoding toolkit. 4. Solving the geometry puzzles. 5. Your homework mission. And finally, 6. Education intertwined with morality. Let's dive right into Section 1, the glory of discovery, uncovering the truth. Our big idea for today is simply this. Missing information, it's never a dead end. When you look at a geometry diagram and you realize you don't have all the numbers, honestly, don't panic. This is a brilliant opportunity to apply the rules we know, set up our equations, and literally turn that limited information into crystal clear answers, just like a true detective solving a case. Moving right along to Section 2, why angle relationships matter. Because you might be asking the ultimate question right about now. Why do we even care about angles in the real world?
Well, when you master angle rules, you aren't just doing math on a piece of paper. You're gaining the exact skills needed to solve massive puzzles in construction and building. This ensures that real structures are built safely, because, hey, nobody wants to build a leaning tower by mistake, right? You use these exact same principles in major design projects, and incredibly, even when coding the collision physics into your favorite video games. It's everywhere.
Which brings us to Section 3, your geometry decoding toolkit. Let's get our math tools ready.
Okay, let's open up that toolkit and look at two of our most powerful tools. First up, complementary angles. When you know two angles form a perfect 90-degree corner, you just subtract the known angle from 90 to find the missing piece. Super simple. On the flip side, we have linear pairs, which form a completely straight line. These are known as supplementary angles because they add up to 180 degrees. For these, you just subtract the known angle from 180.
Having the tools is great, but knowing exactly how to use them is where the magic happens. So here is your step-by-step process. Step 1, identify the angle relationship. Ask yourself, are they complementary, supplementary, vertical? Step 2, translate that visual straight into an algebraic equation using variables. And step 3, once you have your answer, double-check your work logically. Look at the number and say, does this actually make sense for the picture I'm looking at? Oh, and a quick pro tip, always remember to label your diagrams. And above all, just be patient with the process. All right, Section 4, solving the geometry puzzles. We have our toolkit, we have our strategy. Let's dive into some practice cases. Let's crack open example 1. The diagram gives us our very first clue. Angle A is exactly 45 degrees. It's sitting right next to angle B, and together, they form a perfectly straight line. So the mystery here is, what exactly is angle B? Using our toolkit rule for linear pairs, we know a straight line is always 180 degrees. So we simply write out our equation, 180 minus 45. And boom, we get our incredibly satisfying conclusion. Angle B is exactly 135 degrees. Case closed. Now for example 2. This time, we're looking at vertical angles. You know, those are the angles directly opposite each other when two lines cross. Angle 1 is described algebraically as 2x minus 5. Angle 2 is x plus 10. Because vertical angles are literally always equal to each other, we have a very clear path forward for our investigation. What's really fun about this setup is how algebra and geometry team up. Since the vertical angles are equal, we just set our equations equal to each other. 2x minus 5 equals x plus 10. When we solve for x by moving the variables around, we find that x equals 15. Then we plug that 15 right back into our original expressions, and we discover that both angle 1 and angle 2 are exactly 25 degrees. The math perfectly balances. For our final puzzle, example 3, we are definitely leveling up. We're looking at a multivariable situation along a straight line. Pulling all the clues together gives us our master equation. x plus 20 equals 180.
Let's break down those final math steps. First, we combine our like terms, right? So that gives us 2x plus 20 equals 180. We subtract the 20 to get 2x equals 160. Divide by 2, and we find our x value is 80. So our two hidden angles on that line are 80 degrees and 80 plus 20, which is 100 degrees. Notice how 80 and 100 add up perfectly to our 180-degree straight line. It's just beautiful.
Section 5, your homework mission. It is solo practice time. You've seen it done, and now you are totally ready for this.
Here are your 5 mission objectives. Go ahead and just hit pause on this explainer right now so you can jot these down. Apply your geometry toolkit. Remember your rules for supplementary, vertical, and complementary angles. Take your time, draw the diagrams if it helps you visualize it, and solve for those missing pieces. You've got this. Good luck.
And finally, Section 6, Education Intertwined with Morality.
Before we completely wrap up, I want to step back from the numbers for just a moment to look at the deeper philosophy behind why we learn all of this in the first place. The simple truth is this: education without morality will hurt. Think about it. What is the point of being incredibly smart, of being able to solve complex equations or design massive structures, if we take that education and just make bad choices that end up hurting ourselves or the people around us? A sharp mind absolutely needs a solid moral compass to guide it.
This actually ties beautifully into a promise found in Romans 8:6-7. It promises genuine peace of mind to everyone who keeps their mind spiritual. When you combine your hard-earned education with a real focus on godly wisdom and morality, the result isn't chaos, it's profound peace. And honestly, that is our exact experience, and the experience of so many who engage with this way of learning.
Which brings us right to the end of our journey today, leaving you with one absolutely vital question to ponder. You now have the mathematical tools to uncover hidden geometric truths, and you know the importance of anchoring that knowledge in strong moral character. So, what will you choose to build with your education? Keep learning, keep discovering, and I will see you in the next explainer.